Welcome back to this tutorial series on implementing numerical methods in Python. And in today's video, we're going to do a short follow-up on the previous video on Newton-Raphson's method. So, as I stated earlier in the video, that the Newton's method requires a good enough initial guess. So, the bisection method is actually frequently used to feed into Newton's method as an initial value. So what I'm going to do here is we have our root finding method, our root finding file here, which contains our bisection method defined in a previous video. And so what I'm going to do here is I'm going to actually import this. So we're going to say from root finding import bisection. And so now what I'm going to do is I'm going to feed our initial value, the bisection method of our function. And remember, this is cosine and sine. This is a cosine as our function. So we're going to choose 0 as our A, 2 as our B, and our tolerance is, let's say, 1e to the negative fifth. So let's plot this out. Enter in function. Hold on. Need to comment this out again. Now let's run this. So here we have it. We have, this is the output from our bisection method. So we have our A, we have our B, and it shows our M division. And so we subdivide by halves until we have an approximate root. And then we feed that into our Newton's method. And we actually need only 2 iterations of our Newton's method and 18 iterations of our bisection method. And so now what I can do here is I can say print new line x sub n 1, print out that, and then what we can do is we can just simply print out string of our x sub n plus the string of our x sub n plus 1. So now what we can do is we perform this function. So here we have our 18 iterations from bisection's method, and then here we have our 2 iterations from our Newton's method. So here we have our initial guess, we approximate our next initial guess, and then we treat this as our current initial guess, and then we approximate the next the next initial guess. And so this is an extremely cool tool to use. Instead of using the bisection method for an eternity, for let's say like 50 iterations to find a good enough approximate root. So let's say if we were actually to find this to -10 tolerance, and we were to run this again, it was to take us 35 iterations of the bisection method and only 2 iterations of the Newton's method. So what we can actually do is we can simply approximate some kind of initial value using the bisection method to, let's say, -4 tolerance. We spend 15 iterations on bisection and then 2 iterations on Newton's method. So this is a cool way, an application of actually finding the root of a function using Newton's method, while also implementing the bisection method. So hopefully you guys have learned a lot by this, so stay tuned for future videos.